I'm Will from Rigetti. Great to see everyone online. Today I want to talk about our co-standard device or coherent standard device. So uh, at Rigetti, we are a full stack quantum computing company focusing on superconducting qubits. We operate our own quantum captive Foundry, where we make qubits for ourselves, but we also have opened up access so that other researchers or any small businesses in the field, if they want to experiment and send arbitrary designs our way, we're happy to fabricate those and see what kind of results we get. But in our effort to scale up our own quantum computers, we found that in this complex system, it's really tough to get reliable, fully tested RF components and everything else that's going on the inside of the fridge. And that is mostly held up by the bottleneck of fridge space and the ability and access to have a fully validated systems integration test with qubits in the loop. So in our interest to allow folks out there to innovate across the entire stack and the entire cryo-RF chain, we are introducing a coherent standard device where we are going to have pre-characterized qubits available for anyone to put in their own fridge, and then they are able to measure those qubits, see how the results stack up to the data set that we're going to publish to them, see if there's differences within their signal chain, and they can use new components, any advancements, however they want to, whatever they're working on, whether it's amplifiers, new attenuation schemes, some other way to condition the signal better. You can test them against actual qubits. Additionally, if anyone is standing up their DIL fridge for the first time, we understand how it can be like a needle in a haystack when trying to figure out what's going wrong if you're not getting the measurements exactly as you had anticipated. So with a coherent standard device, you could take the fab variables out of the picture there. So we can standardize our fab, and then you just have to worry about the innards of the fridge and what measurements you're getting. So here is a picture of our co-standard device. All of this is offered within the context of Rigetti's Foundry Services MSA. So not only are we offering custom designs that I mentioned, but you can just get standardized qubits off the shelf to put into your fridge to validate your setup or to test further with any improvements that you're making across the stack. We've found that when you want to test the reliability of your components and to ensure that there's not any way that they're introducing extra noise into your system, that it's really best to validate that setup with qubits in the loop. There's only so far that room temperature and benchtop testing can get you. So what we have here is a 5mm by 5mm device prepackaged with SMA connections. It has 2 bare resonators, 3 tunable qubits, and 3 fixed qubits. So you can look at the parity differences between the qubit relaxation and dephasing times. And that's going to come with a data package that's letting you know what frequencies are these qubits at, what frequencies are the resonators at, so you don't have to spend a ton of time sweeping for those, as well as what were the coherence times that we measured in-house. Now, these are analog devices. You're going to expect some differences in your own setup. However, this will give you a great idea of how your setup is operating and whether any new components that you're introducing to the signal chain is helping or hurting end qubit performance. So here's a picture here of our Rigetti data center, just showing that we operate a bunch of different fridges with a bunch of different devices, which means we need tons of cryo-RF componentry and electronics to ensure that we are actually getting the QPU performance for the end algorithms that we're trying to run. As with our Foundry services, where we see us opening the capacity so that researchers can get farther and further the field, we understand that innovation is truly needed across the stack. We're projecting that qubit counts are only going to grow exponentially over the next couple of years. That also means that the signals coming off the chip and that have to fit in the fridge and be conditioned properly and not add extra noise, and however you're going to go multiplexing all those things, that all is going to have to work, and we need to keep innovating. So it can't just be Rigetti or one entity that's going to be doing that. So by opening up test capabilities and by allowing for other users to do integrated systems testing within their own facilities, is really going to take the entire field further and spur advancement here. So we're interested to hear from just about anyone in the entire quantum ecosystem. If you're operating a fridge, if you want to get your hands on pre-characterized qubits, if you want to try to design your own devices, your own superconducting devices to fab, we'd love to hear from you. And it's great to see that so many different entities are trying to address this bottleneck of test and measurement support, and allowing vendors across the country access to cryo testing is only going to help everyone here. So thanks.
What do you see as the biggest benefit to this co-standard, and what are you looking for from the ecosystem?
Yeah, as I was trying to state, so one of the biggest bottlenecks is if you're a component manufacturer, and I know Jack touched on this as well, it's really difficult to get fridge time, and then it's almost impossible to get a full system up and running. You'd have to buy the fridge or find access to a fridge, and then you'd have to get your hands on a qubit device that you might have to fabricate yourself, because we don't know of any others that are commercial off the shelf available right now. So by standardizing for any fab variables there and publishing you a data sheet of the coherence times that we were able to measure, you are now able to do system integration tests to validate any new components that you want to introduce into the signal chain. And you can make a qualified statement on whether that makes qubit performance better or worse. And we think that will be immensely helpful, so that there's not as much co-development that needs to happen with every single time a vendor wants to introduce a new component into some system integrator's specific fridge stack. This will allow for the standardization of components going forward in superconducting quantum systems.
And just so for clarity, because we may have some people on this webinar that are not familiar with superconducting quantum computing and know what the nomenclature of fridge is. By fridge, you mean dilution refrigerator. Can you mention the scarcity and the difficulty of these things just for 30 seconds to help people?
Yeah, absolutely. Without market sizing numbers in front of me, the estimate is probably on the order of 500 to maybe 700 dilution refrigerators in America total. I don't know what the worldwide number then would be, but extrapolate out somewhere from there. But these dilution refrigerators, you're operating your QPU in there like as a quantum computer, but you also need to do your full systems validations in there. So there's a push and pull constantly between whether you're using this dilution refrigerator for development or for actually operating these systems over a long term. And that was longer than 30 seconds. But one last thing is these dilution refrigerators, they get down all the way to 10 millikelvin base temperatures. And that's really critical for maintaining the noise environment around our superconducting qubits.
Great, thank you, Will. That was great explanation.